Hey to you, welcome back. Problem number 226, invert binary tree. So in this problem, you have been asked or you have been given the root of a binary tree and you need to invert it, meaning like swap every left and right child node recursively throughout the tree. So if we take this an example, we have here the root is 4, we have 2 and 7, and if we looked at the output, it's 4, 7 and 2, not 2 and 7. If you looked at the child of the node number 7, you will see that it was 6, 9. It's swapped to be 9 and 6. So how we can do that? I would say we can do this in a recursive approach. So at each node, we swap the left and right children. And after that, we recursive on both children. So yeah, this is how we are going to do it. So since we're using a recursive approach, there is something important that we need to think about, which is our base case. So I think our base case, because we call it invert tree, basically a recursive function means that a function that it calls itself. And since the invert tree will call itself, we need to find its base case in which we reach this base case, the function should stop calling itself. Otherwise, the function will call itself like forever. So how we do that? We make if statement here. If we have no root, we will return null. Okay. So I will create first the swap. We'll start here with the swap section, and I guess I will use the classic way to swap in JavaScript. So I will create a temp. It's basically will store the root.left, will store the value of the root.left. And after that, we had root.left will equals root.right. And since we stored the value of the root.left at temp, we could do this. Root dot right will equals temp. And yeah, we can continue. Here. We will use a recursive function. So we will call the invert tree 2 times, one on the right and other one on the left. So we call it again here root.left, and I'll call it again on root.right. Let's run and see if it will work or not. No, I need to return the root, sorry. Yeah, submit the code and see if it work or not. Yeah, it did work. The time space, it will be O of n because we visit each node only once. The space will be O of h, and h will be the height of the tree in the recursive stack. So the best case scenario, I guess it will be O of log of n if the tree was balanced, and the worst case it will be O of n if we have like a skewed tree. We can go through an example so to understand it even better. So let's just clean everything here. Okay. So let's say that we have this. Let's put 2 here. So let's say that we have this as an example here. Okay. So first, we when we run our function, we will swap 1 and 3. So we will have something like that. Basically, when we swap them, the 3 and 1. And okay, let's do this. Okay, so when we have this, we have 1 and 3, and when we swap them like that, this 3 will be 1 and this 1 will be 3. So it will be 2, 3, 1. Okay, and it's a pretty simple. It's really simple. We can do another approach. Alternative approach is to use a press first with queues. And I'm thinking about yeah, let's give it a go. Let's give it a go in this video or create another video for it. Let me think, guys. Let me think. Description here. So okay, let's give it a go. Let's give it a go. So let's just refresh everything here and start. So how we will do it with queues? I'm thinking about we use queue to traverse level by level and swap left and right at each node. Again, let me delete this so the code will be even easier for us to see. So I will put again our base case. So if we have no root, we return null because there's no need to run anything. And I would say, okay, so I will create a queue and it will be an array and it will start with root. Okay, I'll create a while loop here. So while queue dot length is bigger than 0, I would say let node equals queue dot shift. We're taking the element. No. And I would say I will swap. There is a clever way to do swap in JavaScript, which is node dot left, node dot right will equals node dot right, node dot left. Okay. So yeah, and after that I will say if node dot left it's there, I will make queue dot push node dot left, and the same thing, it will be on node dot right, and I will return the loop, return the root. Let's run and see it will work or not. It didn't work because I had a problem here. Node before what? Late node. Reference error, cannot access node before initialization. But it's not before initialization. Node is there. Okay, let me just do it like that. I'll take from the solution that I had before. Run. Okay, I don't know what the wrong thing that I have done. But yeah, I don't know that much. If you know what I did wrong, so just feel free to give it to me. So yeah, this is, I guess, simpler than the recursive approach. So yeah, tell me what is the approach that you prefer more. So yeah, that's it for this video, and see you in the future.